Hello students, in the last session we completed sums that were related to relative motion and then projectile motion. Okay, so we completed all the sums that were related to projectile motion. In this session we will be doing sums regarding uniform circular motion and then we will also complete 21, 22, 23. So these 3 years PYQ will also be done in this session itself. Fine. So let's jump into it. So in the last sessions we have completed around like 23 sums. So let's jump into the 24th one. Let's see what they have given. Two particles A and B are moving in uniform circular motion in concentric circles of radii RA and RB with speeds VA and VB. Okay, so there are like two particles which is moving in an uniform circular motion, which means it has like constant speed. Okay, so in the theory part itself we have seen uniform circular motion actually means it is moving with constant speed. Okay, obviously direction will be changing, therefore velocity is going to change, but the thing is it has constant speed. Fine. Uniform circular motion in concentric circles of radii RA/RB with speeds V and VB. So in this situation, so those two things have two different radius and they also have different speeds VA and VB. Okay, the time period of rotation is the same. So what they have given us time period of rotation, which means capital T is going to be same. The value of angular speed of A to that of B. So now I'll have to relate between angular speeds. Okay, so what will be the formula that I could use for angular velocity? So there are like two formulas that you could actually use, which is like omega, which is equal to v equals r omega. Okay, so that is something that I will be able to use. Fine. So this gives me the relation between linear velocity and then the angular velocity, but in the situation I'll not be able to take ratios because ra, rb, va, vb, everything is given in the variable itself. Okay, so nothing will get cancelled out, so it doesn't make any sense. So that is like one more formula which I could use to get the answer straight away, which is like omega, which is equal to 2 pi divided by t, right? So this formula will be handy because from the question it is clear the time period of the rotation is same. So in both those instances, for both those particles, time period t will be same. Then how will I be able to relate between the angular speed of A of that of B could easily be determined, right? So here what I need to find is like omega A divided by omega B, right? So you'll have like omega A divided by omega B, which is equal to 2 pi divided by the time period. For the first case, let us put it as TA, divided by, for the second case it's going to be like TB. We know obviously TA is equal to TB, right? Therefore these two things will get cancelled out. 2 pi also will get cancelled out. So the ratio is obviously equal to 1:1, right? So the answer here is option 1. So it is pretty obvious, right? If the time period is going to be same, then it actually means it completes one cycle in unit time with respect to both those rotation. Therefore, angular speed should also be same, right? You shouldn't have any doubt in this sum. Let's move on to the next one. Next sum is a particle starting from rest moves in a circle of radius r. Okay, so there is a particle which starts from rest and it is undergoing a circular motion. That too, it starts from rest. Okay, which means initial velocity was equal to 0. It attains a velocity of v0 meter per second in the nth round. So it is pretty obvious this is not an uniform circular motion because it started from rest and the speed got increased and it reached the final velocity of v0. Then obviously this is not a uniform circular motion. Fine. It's angular acceleration. So what they're asking us to find is what will be the angular acceleration. That's what we are supposed to find here. Okay, so the relation, if they're asking us to find like angular acceleration, things of that sort, then we will use like kinematic equation for rotational motion. Okay, for circular motion, right? So here it is clear they haven't given anything that is related to time. Okay, so the kinematic equation that I'm going to choose is like the third kinematic equation. Fine, omega square minus omega naught square, which is equal to 2 alpha theta, because we will be able to find the theta using this velocity that they have given, because in nth round it reaches like v. So with something I'll be able to find like theta. Same way I'll also be able to find the final angular velocity. Okay, that too could be determined, but the thing is we will not be able to determine the time because they haven't given anything that is related to time. Okay, that's the reason why I took the third kinematic equation. Got it? So third kinematic equation will be equal to omega square minus omega naught square, which is equal to 2 alpha theta, right? What I need to find is the alpha. So it is obvious it starts from rest, therefore initial angular velocity will be 0. So this term goes to 0 straight away. So the thing that I need to substitute over here is like for omega I'll have to substitute something, same way for theta I'll have to substitute something, right? So here at the end of at the end of n rounds, you got the velocity to be the v naught. Okay, so in n round, how much theta it would have actually covered? So for one round, the theta that it is going to cover is like 2 pi. Then for n rounds, it is obviously 2 pi n, right? Straight away thing. Got it? So for theta, I'll substitute like 2 pi n. So this right hand side is almost done now. What I have to find is like omega, right? So instead of omega, what I could actually replace? So what will be the omega, final omega? That's what I need to find here, right? I do not know the time period and those things. Therefore, 2 pi by t is something that I wouldn't be able to use here. So the only option that is left is like v, which is equal to r omega. By the way, we know that the final velocity in this situation was like v naught. Okay, when the velocity was equal to v naught, what was the omega? That's what they're asking us to find in this situation also, because this is actually the final angular velocity. Got it? Therefore, I'll use the relation v, which is equal to r omega. So here I need to get the final angular velocity. So to get the final angular velocity, I know the final linear velocity, which is nothing but v naught, and then the radius is simply the r. Okay, so for omega final angular velocity, I'll substitute v naught divided by r. I could substitute this straight into it. So if I substitute that one straight into it, I'll have v naught square divided by r square, which is equal to 2 alpha. Instead of theta, I'll substitute like 2 pi n. Okay, if I just do the rearrangement thing, I'll end up getting the alpha. Therefore, alpha will be equal to v naught square divided by 4 pi n. Okay, so we'll have like 4 pi n r square. So that will be my alpha. So you will have v naught square divided by 4 pi n r square. That's going to be like option 3, right? So the answer for this question is option 3, right? You should be clear with this sum, right? We have just used the third kinematic equation because they're asking us to find the angular acceleration, right? So whenever they're asking us to find, or if they've given you the angular acceleration in the question, then it simply means it is not an uniform circular motion. It is actually a non-uniform circular motion, right? You should be clear with this sum. You should be clear. You shouldn't have any doubt in the sum. Let's move to the next one. Next sum is, in the given figure, a, which is equal to 15 meter per second square, represents the total acceleration of a particle moving in clockwise direction in a circle of radius r, which is equal to 2.5 meter. Okay, so they've given you the statement and also they've given you the diagram. So the object is moving in a circular path and that too in clockwise direction. It is having an acceleration of 15 meter per second square. They have given you clearly that this is not directed towards the center. It is at certain inclination to that of the center. Then this motion is not an uniform circular motion. It is actually a non-uniform circular motion with its speed increasing. Okay, we have discussed this one in the theory itself, which means it is having a tangential acceleration to it. Therefore, its tangential velocity is also increasing. Okay, same way you'll have like centripetal acceleration, which is responsible for the circular motion of this particle. Okay, so that too, they have given us the radius r, which is nothing but 2.5 meter at any given instant, at a given instant of time. What they're asking us to find is at that particular instant the speed of the particle is. So I'll have to get the speed of that particle in that particular instant. Okay, so to get the speed of that particle, what I could use, v equals r omega, right? So that gives me the velocity, but I do not know anything that is related to omega. Therefore, this equation is not possible for us to use. Okay, so here only thing that I've given is the acceleration. Okay, so from that acceleration, net acceleration, I'll be able to get the centripetal acceleration. We obviously know a centripetal is nothing but velocity at that linear velocity for that particular centripetal acceleration square divided by r, right? So what we need to find is that particular velocity at that instant, right? So to get that velocity, what I need to know is the centripetal acceleration. Instead, in this situation, they have given us the net acceleration. So to get the centripetal acceleration, just resolve it. You will end up getting the centripetal acceleration, right? So the centripetal acceleration will be directed towards the center, and this will be my a tangential. Okay, so in this case, obviously we do not want to know the a tangential. Only thing that we need to know is the a centripetal. Okay, so to get the centripetal component, So this A centripetal is actually close to this theta. Therefore, if I resolve this acceleration into two component, tangential and then the centripetal, the component that is close to this degree will obviously be like centripetal acceleration. Okay, so close to the degree is going to be like cosine component, and something that is perpendicular will be like sine component. Okay, we have discussed this one earlier itself. Therefore, A centripetal is nothing but A cosine theta, right? If I just substitute A cosine theta instead of A centripetal, I'll be able to get the particular velocity at that particular instant, which will be the speed of that particle, right? So now everything is known. Just do the substitution, you will end up getting the answer. Okay, so for instead of A centripetal, I'll substitute like A cosine theta, which is nothing but V square divided by R. Fine. If I just put all those numbers into it, I'll end up getting the answer. Therefore, here in the situation, instead of A, in the question they have given us like 15, that was the net acceleration. So cosine theta was equal to 30 degree, which is nothing but V square divided by R, right? Just do the rearrangement thing, you'll get the answer. So for R, I'll substitute like 2.5. Okay, I need to get the velocity, right? So if I do the rearrangement thing, you will have V square, which is equal to 15 into cosine 30 degree, which is equal to root 3 by 2, right? So for cosine 30 degree, I'll just substitute root 3 divided by 2. Okay, and if I do the multiplication, cross multiplication, you will have like 1 2.5 in the numerator, right? So now I have got all those things. Just do the solving, I'll end up getting the answer, right? So instead of root 3, I'll just substitute 1.7 straight away. Okay, got it. So if the square comes to the other side, becomes root. Anyway, let's do the solving now. If I do the cancelling thing, you'll have like 2.5. If those two things get cancelled out, you will have like 1.25. So 1.25 into 1.7, right? So 1.25 into 1.7. If I do the multiplication, you'll have 35, 14, 3 is like 17, 1, 8, 1 to 5. So you'll have like 5, 2, 1, 11, 2.125. That's what you're going to have, right? So 2.125. So this is what you will end up getting. So now I'll just do the approximation thing. Anyway, we are going to take root, right? So I'll approximate this one to 2. So in that situation, you'll have like V, which is equal to root of 15 into 2, right? So 15 into 2 will be like root 30, right? So here to get the options, so let's do a guess to get the answer, right? So root 25 will be equal to 5, okay, and then root 36 will be equal to 6. So this root 30 should be between like 5 and then the 6, right? Obviously it should be between like 5 and 6. It couldn't be greater than 6. Same way it will not be less than 5, right? So that how it is like root 30. That number is also between 25 and then the 36. Therefore you should get answer to be somewhere around 5.5 or 5.6, something like that, right? So let's verify it. So here with the option 4.5 is obviously not possible. 5 is also not possible because that should be like root 25. 6.2, it is greater than 6. That too is not possible. Only value which is like between 5 and 6 is obviously 3. Is obviously option 3. Therefore that should be my answer, right? So the answer here is like option 3, right? You shouldn't have any doubt in the sum, right? If you have to solve it, only thing that is left is like you just put root 2 1.4 and then split root 15 into 2. It's like 5 into 3 gives me 15. So root 5, you just substitute 2.2 and then instead of root 3, you just put 1.7. If you do all those multiplication of 3 values, you'll end up getting 5.7, right? So that thing is tedious and it is like huge part mathematical things come to it. Therefore you do not want to do that thing. Just by guessing the value, you'll be able to mark the answers, right? So you shouldn't have doubt in this sum. Let's move on to the next one. Next sum is a particle moves in a circle of radius 5 centimeter with a constant speed. Okay, so this is circular motion, radius is 5 centimeter and then the speed is also constant, okay, which means it is uniform circular motion and the time period is 0.25 seconds. Okay, so they have given us the time period. What they're asking us to find is the acceleration of a particle. Okay, so it is clear this is uniform circular motion, therefore you will not have tangential acceleration. So only acceleration which is possible is like a centripetal. That's what they're asking us to find here, right? So they have given us clearly only acceleration, therefore it should be like centripetal acceleration, right? So A centripetal will be equal to V square divided by R, right? So here they haven't given any data that are related to velocity. Instead, they have given us something that is related to time period. Okay, so for V, if I substitute like R omega, I'll get the relation between omega and R, so that will be easy for us to solve, right? So for V, I'm going to substitute like R omega and then the whole square divided by R, so this gives me R omega square, right? So that will be equal to A centripetal. Okay, so I'll have to find the acceleration, which is like centripetal acceleration. So just do the solving, you'll get the answer. Okay. So for R, I'll just put in straight away 5 into 10 power minus 2 meters. And then for omega, I'll substitute like 2 pi divided by, so for time period, I'll put in like 0.2 pi seconds, right? So it will be like 0.2 pi, the whole square, fine. Just do the solving, you'll get the answer straight away. Okay. So here, pi it will get cancelled out, and then this will be like, yeah, this is going to be like 2 by 10, therefore that will be like 10 square, right? So 10 square, 10 power minus 2, so these two things will get cancelled out, right? So only thing that I'll be left with is like 5, therefore the answer here is 5 meter per second square, which is nothing but the option 4, right? So this is like a simple sum, you shouldn't have doubt. Let's move on to the next one. Next sum is statement based sum. Let's see what the sum is. A stone tied to the end of a string of 1 meter long is whirled in a horizontal circle with constant speed. Okay, so you have tied a stone to a string and then you are just spinning it. That's it. Fine, with a constant speed. If the stone makes 22 revolution in 44 seconds. Okay, so this is uniform circular motion. They have given us the number of revolution with respect to the time. Okay, 22 revolutions and then it took like 44 seconds. What is the magnitude and direction of acceleration of the stone? So the thing that I need to find here is the magnitude and direction of acceleration. It is pretty clear from the question. This is actually uniform circular motion. Therefore, you will have only centripetal acceleration. So that acceleration will be directed towards the center, right? So, so direction along the radius towards the center. First thing could be the answer. Away from the center, that is not possible. Tangent to the circle, that too is not possible. Direction along the radius towards the center, so either the answer could be like option 1 or it could be like option 4. So these two in one of those two options will be my answer, right? So only thing that I need to find here is the magnitude. Either it should be like pi square or it should be like pi square by 4, right? So to get the magnitude of centripetal acceleration, AC will be equal to v square by r. In the situation, let's put like r omega square, so that will be handy, right? So for r, radius is like 1 meter long. I'll just substitute 1 into, for omega, I just need to put in 2 theta divided by time, right? So to get the theta, what I could do is, here they have given us like 22 revolutions, so it will be like 22 into 2 pi. Got it? Divided by the time taken, which will be like 44 seconds. Fine, the whole square. That will give me the A centripetal. So if I do the solving, 44 will get cancelled out, and then only thing that will be left is like pi square. So A centripetal will be equal to pi square. So from these two options, it is pretty clear. Option 1 should be my answer, right? So the answer here is like option 1, right? You shouldn't have doubt with the sum. So these are like simple sums, right? Let's move on to the next one. Next question is, a particle moves along a circle of radius 20 by pi meter with constant tangential acceleration. Okay, so they have given us tangential acceleration, then this motion is obviously non-uniform circular motion, right? Okay, if the velocity of the particle is 80 meter per second at the end of second revolution after the motion has begun, which means it started from rest, and then after completing two full circle, the velocity of that particle was equal to 80 meter per second. That's what they have given. What they're asking us to find is the tangential acceleration. So I'll have to get the tangential acceleration. So if I draw the diagram, you'll get something like this. There is an object which is moving with radius r, that is equal to 20 by pi. So in that case, it has completed two full revolution. Okay, so after completing two full revolution, the velocity, final velocity was equal to 80 meter per second. Okay, so if that was the case, then what should be the tangential acceleration? So what should be the tangential acceleration along the tangent? That's what I need to find. Okay, so this is nothing but a kind of like straight line motion, but the thing is, it is moving in a circular path. That's what they have given over here. So what I need to get here is the tangential acceleration. So to get the tangential acceleration, just imagine this motion as if it is a straight line motion. Okay, so what should be the acceleration so that the object gets 80 meter per second at the end of covering this distance? That's what I need to find. Okay, so we do not want to worry about the centripetal acceleration because centripetal acceleration is good enough to hold this object to move in a circular path. Okay, and by the way, they are not asking us to find the centripetal acceleration at the end of that instant. Only thing that they are asking us to find is the tangential acceleration. So I'll be able to solve this sum considering same way as that of the linear motion sums. Okay, so to get the answer for this sum, I'll just use the kinematic equation for the linear motion itself straight away, because a tangential is that nothing but the linear acceleration, right? Okay, you should get that understanding. Fine. So if I do the solving, you'll have here also they haven't given us anything that is related to time, so I'll choose the third kinematic equation. Okay, so the third kinematic equation is v square minus u square, which is equal to 2as, right? So here it is pretty obvious. Final velocity was, initial velocity was 0, final velocity was equal to 80, and then a is nothing but the a tangential. That's what I'll have to substitute here. So instead of s, what I could do is I'll be able to substitute the circumference of the circle into 2 because it has completed like 2 revolution. Okay, now just do the solving, you'll get the answer. Okay, so for v, I'll substitute like 80 into 80, which is equal to 2. A tangential is the thing that I need to find, into s. So to get the s, it's like 2 pi r, fine, for one revolution. In this case, you have got like 2 revolution, therefore it will be like 4 pi into r. Radius was equal to 20 by pi. Okay, 20 divided by pi. Just do the solving and rearrange it, you'll get the answer. So if I do the solving, pi will get cancelled out, and then zeros and zeros will get cancelled out. So 4 2 gives me 8, therefore that 2 will get cancelled out, and then you got like 2, so this will be like 40. Okay, so a tangential was equal to 40 meter per second square. So that will be my answer, which is nothing but option 1 in this case. 40 meter per second square was the answer, right? You should be clear with this sum, right? This is a kind of linear motion sum. Only thing is the same object is moving in a circular path. That's it, right? Let's move on to the next one. This sum is also easy one. Let's see it. Two particles having mass capital M and small m are moving in a circular path having radius capital R and then small r. Okay, so they have given us the mass and then the radius. What they're asking us to find is if the time period are the same, then the ratio of angular velocity will be, right? So it is pretty obvious. We have seen such a kind of sum, couple of sums ahead. Okay, you should be clear. So in this situation, they have given us the time period and they're asking us to find the ratios for angular velocity. Therefore, omega will be equal to 2 pi divided by t. It doesn't depend on the mass, or it doesn't depend on the velocity. It doesn't depend on the radius. Okay, so these three parameters doesn't come into picture. Therefore, the thing is omega will be equal to 2 pi divided by the time period. So if that was the case, then time period is same, therefore angular velocity has to be same. If I take ratios for it, you'll end up getting 1:1, which is nothing but 1 in this case, right? The answer here is option 1, right? You shouldn't have doubt. All right, okay. So in the previous sum, they have given us between radius and then the velocity. In this situation, they have given mass and then the radius. Okay, so it doesn't depend on any of those parameters, mass, radius and velocity, right? That's what you need to know, right? You shouldn't have doubt in this sum. Let's move on to the next one. From this sum onwards, we will be doing sums that are from the year 21, 22 and 23. Okay, so you get around like 6 sums. We will do all those 6 sums. Let's see the next one, which is like 31st question. You have a small block slides down on a smooth inclined plane. So there is a block which is sliding down on a smooth inclined plane. Smooth actually means there isn't any friction between the block and the surface. Okay, so that is what is meant by smooth inclined plane. Fine. So we will do more sums that are related to friction in the next chapter. As if now this might be the new term that you are encountering, but the thing is the formula and all those things will be from motion in the plane itself. Okay, so the question is, a small block slides down on a smooth inclined plane starting from rest at time t equals 0. Fine, so it starts from rest and then it slides. Fine, so initially the velocity was equal to 0. Okay, which means u equals 0. Then they have given us, let Sn be the distance traveled by the block in the interval t equals n minus 1 to t equals n. Okay, so here nth second, so that's what distance traveled by the block in the nth second. Fine. So this is a formula that we have seen in a motion in a straight line chapter itself. Therefore we will be using that formula. Okay, so that is the formula, right? Sn will be equal to u minus half g to n minus 1. Okay, so we will use that formula straight away. In that formula, I have already told you that I have put the negative sign straight away into it. Therefore, while using like gravity, you shouldn't put any extra negative sign. Okay, so we should be clear with that formula that we have discussed already in the previous chapter. Okay, so I'll use that formula. So Sn actually here is distance traveled in the nth second. Okay, so nth second actually means distance traveled by the object in the first second. What should it actually be? The final time should be like t equals 1 and the initial time will be like t equals 0. So that will be the distance traveled in the first second. So distance traveled in the second will be like t equals, and the final time t should be equal to 2 and the initial time should be like 1. Okay, so that is how I would have derived that formula. You should be clear with those things. Fine, so I'll use that formula straight away to solve this sum. So what they're asking us to find here is then the ratio Sn divided by Sn plus 1 is. So I'll have to get the ratio for Sn divided by Sn plus 1. Okay, so first let me draw the diagram for this question. So you'll have an inclined plane, and then you are having an object that is placed on the inclined plane. So this is sliding down the inclined plane, that too the surface is actually smooth. Okay, so that is how it is. So as it is smooth, you are having like gravity g that is acting downwards. Then now I'm going to split this component into two component. Okay, so we'll be doing the splitting more often in the next chapter, laws of motion. As if now, if you are familiar with the theory part, okay, I've taught you that one extra part which is like projectile motion on an inclined plane. Okay, so if you are familiar with that thing, okay, anyway that part is not needed for the NEET. So if you have listened through that theory part, you should be clear with how I'm splitting this component. Okay, even if you have confusion, there isn't any problem. Anyway, we'll do the splitting in the next chapter, which means in the laws of motion chapters. Okay, so here you have like gravity which is like acting downwards. Then what I'm going to do here is, generally when you have an object on an inclined plane, this is how we'll split it. So one thing will be perpendicular to the surface. Okay, so that will be like one split, and the next split will be like parallel to that surface. Okay, so now I'll have to insert theta into this equation. So here the theta that I'm going to consider is actually the theta of that inclined plane. Okay, so this will be my theta. That's what I'm going to consider over here. Okay, so this is my theta. So where should I match this theta with this resolution that I have made over here? Either I could match with the lower one or I could match with the upper one. Okay, so how should I actually match this? So let me draw a diagram. Fine. So you have one angle. Okay, so what I'm going to do here is I'm just going to flip this angle like 90 degrees. So if I flip this angle 90 degree, then what will happen? So this angle, so one component will be perpendicular and then it cuts the horizontal one. Okay, same way other line will cut this previous line at 90 degree. Okay, therefore in this situation obviously these two thetas will be equal to each other, right? So the theta over here and then the theta over here are actually equal to each other. So if I just consider the same way for this diagram, then the horizontal line here is cut by this G perpendicular, right? And the same way the horizontal line for this one is actually cut perpendicular by this line. Okay, so obviously the theta over here should match with the theta over here. Okay, so same logic, right? You take an angle and then flip it to an angle of 90 degree, and then you just join those two things together. Then obviously those two angles are just the same thing, therefore those two thetas should be same, right? So here these two thetas are actually same, therefore this should be my theta. In this situation, the component that is close to theta will be like G cosine theta, obviously. Same way, the component that is responsible for the motion of the motion of that block from the slide is actually G sine theta, right? So this component will be responsible for motion of that block, which will be equal to G sine theta, right? So now I have got the component of G which is responsible for the motion of the block. Now I am ready to use the formula which is like Sn. Okay, I know the formula straight away, therefore I'll just use it. So you will have like U minus half g to n minus 1. Okay, so in this situation, the component of g which is responsible for the motion is actually g sine theta. Therefore, I'll use it straight away, which is like g sine theta. You should be clear with the thing that I've done over here. And then you will have like 2n minus 1, right? So for Sn, you will have like 2n minus 1. So that will be the first one. So in this case, the initial velocity was equal to 0. Therefore, that goes to 0. And then how should I actually take the ratio is Sn divided by Sn plus 1. So for Sn plus 1, I'll just put 2n plus 1 minus 1, right? So the next factor that I need to get is like Sn plus 1. So that will be like Sn plus 1. So you'll have like Sn plus 1, which is equal to u. Again, this u goes to 0. Therefore, you'll have like negative half g sine theta, and then you have 2n minus 1. Instead of n, I'll substitute like n plus 1. Therefore, you will have 2n plus 1 minus 1, right? So you should be clear with the bracket stuff that I've done over here. Fine. So now let's do the solving. You'll get the answer straight away. That's it. Simple, easy sum. Fine. So half it will get cancelled. Negative negative it becomes positive. G sine theta will get cancelled out. And then you have like 2n minus 1 in the numerator. Fine. So you got like 2n minus 1 in the numerator. Same way in the denominator, if I do the inner multiplication, you'll have like 2n plus 2. That's going to be like 2n plus 2 minus 1, which will give me 2n plus 1 in the denominator. Okay. So the answer here is 2n minus 1 divided by 2n plus 1. That should be my ratio. So if I consider it over here, you will have 2n minus 1 divided by 2n plus 1. That will be like option 3 in this case. Okay. So you should be clear with this sum. So this is actually the easy sum, right? You don't have any much thing to solve. The thing is, you should be clear with the concept that I'm telling you here, okay? So here I just matched the theta with the resolution of vectors that I've done for that block, okay? You should be clear with that matching, fine? So even if you didn't understand it properly, it doesn't matter. Anyway, in the next chapter, we will be doing that resolution again one more time, okay? The thing is, I just matched the theta with the theta in that block, okay? Then what I did is actually the component that is responsible for the motion is g sine theta. I took that component and then I used it in the formula that I've studied already in the last chapter, which means in the motion in a straight line chapter, okay? So I just took that formula Sn, which is equal to u minus half g 2n minus 1. I put in that formula. I used that formula and then I put in g sine theta into it. I just solved it to get the ratio. That's it, fine. So this is one of the easiest sums. You shouldn't have any doubt in the sum. Let's move on to the next one. Next sum is a little bit tricky. Let's see what the sum is. A particle moving in a circle of radius capital R. Fine. So there is a particle which is moving in a circular path with a uniform speed takes time period capital T to complete one revolution. Obviously, time means capital T is time period, which means time taken to complete one revolution. Okay. If this particle were projected with the same speed, so if I'm just going to throw the particle with that same speed, in that situation, at an angle theta to the horizontal, the maximum height attained by it is equal to 4r, where r is the radius of the circle, right? So that's how it's going to be. The angle of projection theta is then given by. So I need to find the theta in the situation. Fine. So they have given us the relation here as h maximum height reached h will be equal to 4 times capital R, where capital R is the radius, okay, of the circular path. Okay, so you have like two conditions. I'm just going to consider an object which is moving in a circular path. I'm just going to consider that to be the first case. If I'm going to throw the projectile, that object with that particular speed, with that the speed was actually equal to that of the speed of the rotation of the particle in circular path. Okay, so if I'm going to throw that object with that same speed that it actually had with the circular motion, in that case maximum height reached h was equal to 4 times the radius. Okay, that's the hint that they've given over here. If that's the case, then what should be the theta? I need to find the angle of projection theta in the situation. So the hint here is h maximum height reached will be equal to 4 times capital R, where R is the radius. Okay, so instead of capital H, I'm just going to substitute obviously u square, right? So the initial velocity, let me put it as u square sine square theta divided by 2g, which will be equal to 4r, where r is the radius, right? So if this was the case, then I just need to find here the initial velocity u, right? So if I just get the initial velocity u in terms of initial velocity u actually means the uniform speed for the rotation of that particle. Okay, so if I know I'll be able to match this u with the velocity of the circular path with the velocity of the particle while it is moving in a circular path. Okay, so if I just match those two things, then I'll end up getting the u. If I put in the u over here, then if I do like slight rearrangement thing, then I'll obviously get the theta, right? So you have the combinations of radius and all those things into it. Only thing is I just have to get the value for u, and if I do the rearrangement thing, I'll get the value for theta, right? So to get the value for u, the only hint over here is the first statement, which is like omega. Okay, so here v will be equal to r omega. So v was equal to r omega. So here I just need to get the u. So instead of v, I'll just put in u because the rotation here is uniform speed, which means uniform circular motion. Therefore, you are going to have constant speed, which is like u, which is equal to r omega, right? So instead of r, I'll put in capital R, which is the radius of the circle. And then for omega, here what they've given us is the time period, which is like capital T. So in the situation, I'll not be able to put in omega because they have given us the time period capital T. So obviously you have this another one relation, which is like omega, that is equal to 2 pi by T. Therefore, instead of omega, I'll substitute 2 pi divided by capital T. Okay. So now I'm just done with this part. If I just substitute this u into the above equation, I'll end up getting the theta. Okay. So once I get the theta, I'll be able to match it with the options over here. So let's solve it. Fine. So here u will be equal to 2 pi r divided by capital T. So in this case, you have got like u square. Therefore, I'll substitute like 4 pi square r square divided by t square, right? So instead of u square, I did substitute, I squared it and I substituted it. Then you have got sine square theta divided by 2g, which is equal to 4r, right? If I just cancel it out and do the rearrangement thing, I'll end up getting the answer for theta. So let's do the cancelling stuff. So here you have got like 4, those two things will get cancelled out, and then 1r, r square. So those two things will get cancelled out. You'll be left with single r. Then you have got nothing else to get cancelled out, right? So just do the rearrangement thing, you'll get the answer. So, so you will have sine square theta, which is equal to 2g t square. That should be in the numerator, right? So you will have 2g t square in the numerator. Then on the denominator, you will end up having pi square capital R, right? Fine. So here you have got like sine square theta. So if sine square theta square goes to the other side, becomes root. Therefore, you'll have like root. So instead of sine square theta, I'll just put in sine theta straight away, and then I put a root. So for root, I'll just put half in the power, right? So that too is root, right? Square root, right? So theta will be equal to sine inverse of root of 2g t square divided by pi square r. Fine. So let me match it with the option over that they've given in the question. So you will have theta, which is equal to sine inverse of 2g t square pi square r whole power 1 by 2. Okay. So that should be my answer. Therefore, the answer here is option 1, right? So it just straight away matched with the option 1 itself. Okay. So you should be clear with this sum. This sum is a little bit tricky, but it is actually easy. You shouldn't have any doubt on this question. The thing is, I just matched the maximum height with the 4 times the radius. Okay, so the radius is something that I've got from the other situation, other case. So in that case, that particular object was moving in a circular path with uniform speed, right? So that speed, with that speed, if I just throw it with the projectile, okay, at certain inclination, that theta. Okay, so I just need to get the theta over here. So now I'll be able to match those two different situation. Okay, so you'll end up getting the equation h, which is equal to 4r. Okay, so now you just plug and play, right? You just put in the maximum height formula, and then in order to get that u, what I did is I just went to the first iteration for that circular motion case. So with that circular motion case, I took the equation v equals r omega. So instead of omega, I just put in 2 pi by t as they have given us the time period. Then I did just a little bit of solving and I ended up getting the equation. Okay, so you shouldn't have any doubt on this question. You should be clear. Let's move on to the next one. Next sum is the angular speed of a flywheel moving with uniform angular acceleration. So they have given us you are having angular acceleration, which means alpha comes into picture. Okay, how does it changes? Changes from 1200 rpm. Okay, so 1200 rpm. So they have given it in rotation per minute. Okay, so if needed, we should change it into radian per second. Okay, let me read the question. You'll get it from 1200 rpm to 3120 rpm in 16 seconds. Fine. So here you have got the initial angular velocity and then the final angular velocity. What they're asking us to find is what is the angular acceleration in radian per second square, which means I'll have to get the answer in SI units. Therefore, I'll change this rotation per minute to radian per second for angular velocity. Okay, so let us use the formula straight away. We'll get the answer. Okay, so alpha will be equal to change in omega divided by the time. They have given us the time, same way they have given us the change in omega, final minus initial omega, right? So that will be like del omega divided by t. So to get the del omega, final omega minus initial omega divided by t gives me the angular acceleration alpha. So here to get the omega, what should I do is, obviously I'll have to convert this 1200 rpm to radian per second. Okay, so to change that one, so for the final one you will have like 3120. So that will be the final one, omega f minus omega I will be like 1200 rpm, right? So instead of rotation per minute, I'll have to convert this one to radian per second. So one rotation will be equal to 2 pi. Therefore, so here it is like rotation, which means like 1200 rotation. One minute it just made like 1200 rotation. One rotation will be equal to 2 pi. Then it should actually be 1200 into 2 pi. That gives me the rotation in terms of radian, right? You should be clear with this thing. Therefore, I'm just going to multiply it straight away with 2 pi. Fine. So it is not equal to 1 second. So this rotation has been made in 60 seconds. Therefore, in order to convert this one to seconds, I'll just divide it by 60, right? You should be clear with these kind of conversions. Okay, so you have got like radian per second, right? So the first thing is done. For the denominator, I'll just put in 16 seconds divided by 16. So now I have got the alpha, which is like omega f minus omega I divided by t is done. If I just do the solving thing, I'll get the answer, right? So solving thing is something that's going to be lengthy. Okay, so if I do the solving stuff, you will end up having, see, that too, it is not needed to solve this pi. If I look into the option, it is pretty clear. In all those options you have got like pi and all those things. Therefore, I'm just going to do the solving for rest all other numbers. You'll get the answer, right? So the first thing is like 3120 minus 1200. I just have to subtract it. You will have like zeros 2, so 31 will be like 9, and then you have like 1920, right? So we'll have 1920 into 2 into pi divided by 60 into 16, right? Just let me do the solving. You'll get the answer. Zeros and zeros will get cancelled out. Then you have got like 16 and then 192, right? Let me cancel it out and with a table. So you'll have like 2 in the denominator, and then in the numerator instead of 16. For 16 you have like 2, and then you got like 32. That's going to be like 24, right? Yeah, so then you will have like 12. Yes, then you have got like 2. So the answer here is like 2 into 2, which is like 4. 4 pi will be my answer, which is option 3, right? Fine, you should be clear with this sum, right? So it is one of the simple sum, right? You don't have, you don't want to use too many logic into it. Just alpha gives you del omega by t. For del omega, you just put in final omega minus initial omega. You'll get that stuff divided by the time. That too, they have given it straight away. Only thing here over here, only thing that you need to be careful over here is you'll have to do the conversion between rotation per minute to radian per second, because they're asking us to find the angular acceleration in terms of radian per second square, right? You shouldn't have any doubt on this question. Let's move on to the next one. Next is a ball is projected with a velocity 10 meter per second at an angle of 60 degree with the vertical direction. Okay, so the only catch over here is vertical direction. Okay, you should be clear with this one. Generally, we'll consider the angle with respect to the horizontal, with respect to the ground. In this situation, they are just considering it with respect to the vertical direction, which means with respect to this vertical line. So that will be like 60 degree. Then the angle that we usually take is going to be like 30 degree. Okay, I'll draw the diagram, we'll get it. What they're asking is to find is its speed at the highest point of its trajectory will be. So I need to get the speed at the highest point of its trajectory. Okay, which means at the maximum height. So that will, so you are just going to draw an object with an angle of 30 degree in a projectile fashion. So in this situation, it has reached the maximum height. What they're asking is to find is the speed at its highest point. Okay, so the speed will only be the velocity along the x. Obviously, velocity along the y will be like 0. Therefore, velocity along the x will be equal to u naught cosine theta, right? So instead of theta, I'll have to substitute here as 30 degree. You should be careful in this particular part. They have given a 60 degree with respect to the vertical. In this situation, generally we put in like with respect to the ground, therefore it should be like 30 degree. So you will have Vx, which is equal to u naught cosine 30 degree. So instead of u initial velocity, I'll just substitute like 10 into cosine 30 degree. So cosine 30 degree will be like root 3 by 2, right? So it's just the flipped thing of sine theta, therefore it will be like root 3 by 2. Just do the solving, you'll get the answer. So if I just cancel these two things, you'll have like 5 root 3, which will be my answer. That is like option 3 for this sum, right? You should be clear with this sum. Let's move on to the next one. Next sum is a bullet is fired from a gun at the speed of 280 meter per second. Okay, so you are firing a gun with an initial speed of the bullet which is equal to 280 meter per second in the direction 30 degree above the horizontal. Okay, so I'm just firing it with an angle of 30 degree with respect to the horizontal. The maximum height attained by the bullet will be, so I need to get the maximum height. So they've given us the option, fine. So in this situation, I just have to plug in those numbers into the equation that I've already got. Okay, maximum height equation. You'll end up getting the answer, right? So let me write the equation for maximum height, which will be equal to h, which is equal to u naught square sine square theta divided by 2g. So that will be the equation for the maximum height, right? So for u naught square, I'll put in 280 into 280. Okay, then you'll have like sine square theta. So theta here is like 30 degree, so that will be like half, right? So you'll have like half into half divided by 2 into g. So in the question they have given us 9.8 to put in like 9.8. But when you look into the option, it is pretty clear. These options are not closer. The numbers are not closer. Therefore, I'll just put in 10. Okay. So if the number was closer, then in that situation, I'll put 9.8, because you might end up getting two options. For 10 also, I'll get the option. And then for 9.8 also, I'll end up getting the option. But if I see the option over here, it is pretty obvious. The answers are much spacious. Therefore, even if I put 10, I'll end up getting the correct answer, right? So I'll substitute like 10 over here. Then let me do the solving, right? So if I cancel it out, you'll have like 280. Those two things will get cancelled out, and then you'll have like 140. Same, you'll get like one more 140. And then let me cancel out these two things. You'll have like 70. Zeros and zeros will get cancelled out. So only thing that is left is like 14 into 7. Okay. So if I do the multiplication 14 into 7, that gives me 98, and then put one more 0. So the answer here is like 980 meters. Fine. I did some approximation. Obviously, I just increase the value in the denominator. Therefore, the value that I've got over here should be lesser. Okay. So obviously the answer here should be like 1000 meters, which is like option 3, right? So this is easy sum. You shouldn't have doubt. Let's move on to the next one. This will be the last sum for this session. Let's see this sum. A horizontal bridge is built across a river. Okay, so you're having a bridge on top of a river. A student standing on the bridge throws a small ball vertically upwards. So he is throwing upwards with a velocity 4 meter per second. Fine. The ball strikes the surface of the water after 4 seconds, which means it had moved upwards and then it just fell down, and then it is going to reach the water surface after 4 seconds. Okay, after 4 seconds, what they're asking us to find is the height of the bridge above water surfaces. So I'll have to get the height of the bridge from the water surface. Okay, so in this sum, with respect to this sum, you'll have to be clear with the sign convention. If you end up putting wrong sign convention, then you'll get the wrong answer. Okay, so you'll have to be clear with the negative and the positive signs over here. Fine. So I'll draw the diagram and I'll make it clear for you. So you are having a bridge. Fine, and then I need to find the height of the bridge from the water surface. So what I need to find here is this h. Okay, so this is what I need to find here. That is a student who is standing on the bridge, and then throws he throws a small ball vertically upwards. Okay, from this point, let me consider this point to be my origin. Okay, so because from that point he is throwing it, right? So that should be my origin. So from here he is throwing it upwards. So from here he is throwing upwards with an initial velocity u, which is equal to 4 meter per second. So what will happen through to that small ball? You will have the ball to travel upwards, and then it goes to the top. The velocity becomes 0, then it starts accelerating downwards, and then at some point it hits the ground. So the time at which it hits the water will be equal to t equals 4 seconds. Okay, so these are the data that they have given us. What they're asking us to find is the height. Fine. So obviously I'll have to use here kinematic equation, right? So to use the kinematic equation in this case, let me consider. Okay, so here you have to be careful with the sign convention, because here the ball is moving upwards and then it is coming downwards. So you'll have to put positive sign for the initial velocity. Same way, the acceleration due to gravity will be like negative g. Fine. So the height covered here from the origin will be like downwards, therefore you'll end up getting the height in negative. Okay, because from the origin the height of the bridge is actually measured downwards, right, with respect to the water. Therefore the height, you will end up getting the height to be like negative. The thing that I'm insisting here is you should be clear with the sign convention. Okay, if you don't put in proper signs, negative and positive, you'll end up getting the wrong answers. Okay, so let's solve this sum. So equation that I'm going to choose here is the kinematic equation. Either I could choose the first one, second one, third one. Okay, so in this case I'll just choose the second kinematic equation, because that gives me the relation between the displacement and then the time. Okay, so here the displacement is something that I need to find, that will give me the height of the bridge. Okay, same way time is something that they've given in the question. Okay, so therefore the best option is like to choose the second kinematic equation, which is like s, which is equal to ut plus half at square, right? So here the equation that I choose is like s, which is equal to ut plus half at square. Fine. Now if I just substitute numbers into this equation, I'll end up getting the height of the bridge from the river. So h, so instead of s, we'll get the height of the bridge, which is like h, which is equal to ut plus half at square, right? For u, that was a throw upwards, right? Therefore it should be like positive. So you will have like 4. The total time taken will be like 4 seconds. So that will be like 4 into 4 plus half. For a, I'll put negative g, because acceleration due to gravity was always downwards. Even when the ball was moving upwards, the gravity was pulling it downwards. So even in that situation, I'll just consider it to be the negative acceleration, right? You should be clear. Therefore, for a, I'll put in like negative 10. And then you have got like t square, which will be the time taken. The same 4 seconds. So I'll just have to square it, which will be like 4 into 4. Okay, you have to be clear with the sign convention. So here I just threw it upwards, therefore this term will be like positive, because I just throw it upwards, I didn't throw it downwards, instead I threw it upwards. Okay, therefore that term will be like positive. Obviously the second term will be negative, because acceleration due to gravity was always acting downwards, right? So if I do the subtraction thing, I'll end up getting the height. So here you have got like 4 into 4, that's going to be like 16. So if I do the cancelling stuff over here, you will have 2 minus 10, those two things will get cancelled out, and then you will be left with minus 5, right? So you have got like 2 4s, right? So if I just factor it out, you will have 16 factored out into the bracket. You will have like 1 minus 5, that will give me like minus 4, right? So 16 into minus 4, so that should be my answer. So if I do the multiplication, 16 into 4, 6 4s are 24, and then you have got like 64, that will be like negative 64 meters. So the thing is, I've got the height to be like negative because the object has reached the origin. The origin here is like is the topmost point of that bridge, okay? The point where the student is standing. So that will be my origin. Obviously, now the ball or the stone that I've thrown is actually traveling downwards, which means it is moving below the origin. Therefore, I just got the height of the bridge to be negative, right? You should be clear with the signs that I'm just using here. So whenever you're going to use like kinematic equation, just put the sign convention properly, right? You'll end up getting the right answer. If you don't use the sign convention properly, you might end up adding those two equations, which will result in the addition of those two parts, okay? So here, as these two things are opposite, which means one is like actually throwing it upwards, but what actually happens here is it is just moving below the origin. Therefore, you ended up getting the height to be negative, right? Okay, so the height of the bridge from the surface of water is like 64 meters. The reason why I have got it in negative is because the answer is below the origin, okay? Therefore, I got it in negative, okay? But the thing is, they're just asking us to find the height of the bridge above the water surface, only the magnitude that they're asking us to find. Therefore, it should be like simply 64, which is option 3 in this case. So the answer here is option 3, which is 64 meters, right? You shouldn't have any doubts in all those sums that we have discussed, okay? So the majority of the sums that we did in this class were related to uniform circular motion, right? And then we also did 3 years PYQ, which means 21, 22, and 23. Those 3 years PYQ was also done, right? You shouldn't have any doubt in all the sums and the theory that we have discussed. You should be clear with all those things, fine. So in the next session, we will be doing laws of motion theory and all those stuffs, okay? So with this, the video gets completed. Bye.